All right, welcome back. So you saw what happened when I tried to solve this by hand. So it was possible, but I just gave up on it because I really wanted to show you to do this with a computer, okay? So let's start just over, okay? So first thing I'm gonna do, I'm gonna solve the homogeneous equation. So the homogeneous equation, remember, we're setting it equal to 0, y equals e to the rt. So we get, as our characteristic polynomial, r squared plus 2r plus 2 equals 0. R equals -2 plus or minus square root of 4 minus 8 over 2. So it's -1 plus or minus I. Okay, so our homogeneous solution is y0 of t equaling e to the -t c1 cosine t plus c2 sine of t. Okay, now let's do the particular solution. So the particular solution, I noticed that, hey, you know what? I've got this e to the -t cosine t. That's part of my homogeneous solution. That means that things are going to be a little bit harder. Okay, so my particular solution is going to be, so looking at the form on page 176, so that's going to be t to the 1, because s equals 1, e to the -t, a t plus b cosine t plus t e to the -t ct plus d sine of t. Okay, now you saw what happened when I tried to solve that. So let's go ahead. What we're going to do is we're going to do this using a computer algebra system. Okay, so let me go ahead and go to my computer. So let's go to my desktop. I want to make sure that I'm seeing what I want to be seeing. Okay, now I'm going to show you guys first Sage. Okay, so Sage Math is a computer algebra system that you can use. Okay, and it's free. By free, I mean it's free. Okay, you can download it here. Download 9.1 is the latest version. Okay, there's installation procedures for Windows, for Linux, and for Mac. Okay, so you can get it on any platform that you like. Okay, and if you don't even want to do that, you can do Sage Cell Server is the one I'm choosing. Okay, and I can solve it. Now, I could actually solve this whole equation on there. Okay, so let me just show you the whole equation. Now, this is not in the spirit of what we're doing. Okay, this is not in the spirit of what we're doing. So let's, but it's still nice to see that it'll do it. And it'll really be nice when you know, want to check your solutions. So I'm declaring t as a variable, y is a function of t, and I'm going to solve. Dsolve is the differential equation solver. Diff of y with respect to t, second derivative, plus 2 times diff of y with respect to t, first derivative, plus 2 times y equals, I'm using 2, 4 times t times e to the negative t times cosine of t. I'm solving it for y, and then I think I had to do the, let me look at dsolve real quick. I know I have to put in the method, but I want to see exactly what it says. So oh, maybe I don't need to do that. Looks like I don't. Let's see if that'll work. Okay, it did. Let's show our answer. And when I put show, it's just going to show the result in a prettier way. Okay, so there's our answer. K1 or C1 sine t plus C2 cosine t e to the negative t plus 1/2 2t cosine t plus t2 squared. Okay, you got that, right? Now, I'm going to not really do this on here because I want to do it a little faster. So I'm going to go to, I have it on my own computer. Okay, so /sage. I'm opening it on my own computer. It'll open a notebook. It's a little bit faster on my own computer because it's not doing it on the cloud. Okay, I've already got a setup for wanting to do this. Okay, so I'm going to start basically the same thing. Oh, I had done it already. Pretend you didn't see any of that. So t equals var of t. We're doing it a little bit differently. We're not doing it just immediately. I want to show you how to do the steps in Sage. And the reason is because it's a good idea to know how to use the steps, because the techniques, we want to teach you the technique. Okay, so I'm showing you how to do the technique itself. So t is the variable. I'm going to set yp is equal to a function yp of t. Okay, let's set var. Let me just look this up again. I did it already, and I hate that I'm having to look it up again, but you see how it works every time. Defining coefficients. In Sage Math. There we go. Var. Here we go. So I'm going to set var A, B, C, D. Okay. And now I'm going to set y sub p equals, and I'm going to make this is my guess for the undetermined coefficients. T times e to the negative t times 8 times t plus b times cosine of t plus t times e to the negative t times ct plus d times sine of t. Okay. Make sure everything there's, oh, something was wrong. I need to have c times t. Okay. Now I'm going to do the derivatives just to show you. So the diff of y sub p with respect to t, the first derivative, this is just taking a derivative. Okay. Do it again for the second derivative. Okay. Now I'm going to do the, nope, so that sine of t should be on here, so just so that you know, you're aware. Now we're going to do the left-hand side for our particular solution. Okay, so remember that was y double prime plus 2y prime plus 2y equals 4t e to the negative t cosine of t. So the left-hand side is going to be, and I'm going to show it so that it looks nice, diff y sub p t 2 second derivative plus 2 times y sub p, diff y sub p t 1 plus 2 times y sub p. Okay, so I'm going to show that. And this is what we, there should not be an a squared ever. Something went really wrong. I see. Okay. I have up here, did not put a times there, so that was a mistake. You can see the e to the negative at minus b, that's definitely wrong. Let's see if this fixes it. Okay, now that's better. Okay, that's much better. Okay, so this is the left-hand side of the particular solution. I'm going to go ahead, I'm going to go back to the good notes so that we can do this by hand. Okay, so we're trying to do as much as possible by hand and only using the computer. Well, you understand what I mean. I'm trying to show you how you can use the computer, the solver, to make this easier while still demonstrating the problem. Okay, so let me stop sharing here. And start sharing here on my screen. Not yet. There it goes. Okay, let me real quick go back to the thing. I'm going to be just writing this off. So, looking at what I had there, okay, I'm going to have two ct e to the negative t cosine t minus 2at e to the negative t sine t plus 2 I'm just going straight off what it wrote, TCT plus D cosine T e to the negative T, okay, plus 2a cosine T e to the negative T minus 2a plus b, let me write that better, 2at plus b e to the negative t sine of t plus 2c e to the negative t sine of t. Okay, so like I said, if I had given you this problem on a test, I would expect you to show about this much work. And you could even say here, using Sage. Okay. Now, we're going to go ahead and we're going to match. This should equal 4t e to the negative t cosine t. Okay, so now let's go ahead and match the sort of the pieces. Okay, so let's match t e to the negative t cosine t on both sides. Okay, so the left-hand side, that's going to have 2c from here and 2c from here. That's the only place where we have t cosine of t e to the negative t. Okay, so we're going to have 4c equals 4. Let's take 2 e to the negative t sine t. So 2 e to the t e to the negative t sine t. We're going to have a negative 2a here and negative 2a here. So negative 4a equals 0. So we already know c equals 1, a equals 0. Now let's take e to the negative t cosine t on both sides. Okay, so on the left-hand side, okay, that's this whole mess. Okay, we have 2d plus 2a equaling 0. So this is going to give us that, of course, since a equals 0, then d is going to equal 0. Okay, now let's take a look at e to the negative t sine t. E to the negative t sine t. So on the left-hand side, we're going to have what? Negative 2b plus 2c equals 0. But c equals 1. Okay, so that means that b is going to equal 1. Okay, so our total solution is going to be y of t equals c1, e to the negative t, c1 cosine t plus c2 sine t plus our particular solution, is going to have, let's see, c and b both equal 1. So where was our particular solution? Our particular solution was here. So c and b equals 1. So that's going to be t e to the negative t cosine t plus t squared e to the negative t sine of t. Okay, We're almost done here. I want to compare with the answer that we got when we did it just completely by cheating. Okay, so let's go back to the original. Here's where I want to be. Actually, here's where I want to be. So our solution that we got by cheating was this thing. I'm going to write it down. So k2 cosine t plus k1 sine t e to the negative t plus 1/2 2t cosine t plus 2t squared minus 1 sine t e to the negative t. Okay, so let me go back to the good notes where I've written that down. Okay, so this part is the same. T e to the negative t cosine t, that's this, right? T squared e to the negative t sine t, this 1/2 divides that 2, and then we have this thing. So what's extra? We have this extra piece. We have this extra piece of negative 1/2 e to the negative t sine t. But if you know, this one actually, I actually had to redo it because I had forgotten this little thing, this little bit. But this piece, you could consider it as part of this. Okay, so these K1s and C2s, they're not actually the same constants. This minus 1/2 is a constant, so this term you could say is sucked into there. Okay. And that's not the technical term, but you understand what I mean. So it's sucked into the homogeneous solution. Okay. All right. That's it for this section. We will continue with more undetermined coefficients next time.